In part one, we have to deal with some misconceptions within logs, but find the value of p and q for which they would be okay. So I'll look at the top one to start with because that doesn't involve q. And I can write down if log to base 5 of p squared equals log to base 5 of p squared like this, then using the third rule of logs, it must be that this is true. Which implies, now there's two ways you can deal with this. You can either divide through by log to base 5 of p, but consider it equal to 0, or we can subtract and factorize. I'll go with the latter today. So either log to base 5 is equal to 0 or 2, which means that p is going to equal 5 to the power of 0, which is 1, or 5 to the power of 2, which is 25. So two possibilities at the moment. Now we're told that there is a value of p and a value of q, so we're going to reject one of these later on, but got to look at this next part now. So also log to base 5 of q minus p is equal to log to base 5 of q minus log to base 5 of p. Okay, this was the misconception, and what it actually is that you have to divide them. And therefore, it must be that q minus p is equal to q over p. If p equals 1, q minus 1 will equal q. So this is never true. So reject p equals 1. If p is equal to 25, then q minus 25 will equal q over 25. And now we need to find the value of q that will work for this. So 25q minus 25 times 25, that's 625, be equal q. 24q will equal 625, and q will equal 625 over 24. So that's our pair of values. P is 25, q is 625 over 24. Right, on to part 2 of this question. So r is any real number, but it has to be positive, and r is not equal to 1. We need to prove that this statement is true. So I'm going to remember, and we're implying from the left to the right, so we can't start with the right and show that the left is true. So I'm going to take the left-hand side, and I'm going to call it c, and then I can start undoing logs, but I need to call it something first. So let c equal log to base r of a. This implies that r to the c is equal to a. But also c is equal to log to r squared, to base r squared of b. And this implies that r squared to the power of c is equal to b. Now when I think about how I can combine these, and what I can do is this here is actually r to the 2c is equal to b. And if I do the same up here, it's going to be that r to the c all squared, or r to the 2c will equal a squared. And it's going to follow from this. Therefore, b, actually, sorry, they've written it the other way around, so I'll do that as well. Therefore, a squared is equal to b. So I've just taken both of them, I've rearranged them, I've got r to the c, I've got r to the 2c, just then change this to r to the 2c. Okay, it must be that these two are the same, so a squared is equal to b. Now we're asked to solve this, sorry, this was part 2a. I've got a log equation to solve. And we can see there's a cubic involved as well. Remember in part 1 we had a relationship between the base and the base squared. The same thing is happening here. So we're going to use that, and I'll even write it as log to base 2 squared. I can also bring this into the log. So that 2 is actually going to be log to base 2 of 4, which I can then bring together, and it will be log to base 2 of 4 times x plus 2, or 4x plus 8. Now we basically have the result from, we can use the result from part A. Log to base 2 of A is equal to log to base 2 squared of B. So this is B and this is A. Using part A will give 3x cubed plus 26x squared plus 40x is equal to 4x plus 8 all squared. Now I kind of regret, no I don't, I'll do it. I could factorize the 4 out and square it separately, but let's just stick with this. And we've turned it into a cubic to solve. So if I expand this out, I'll get 16x squared. 4x times 8 is 32, so I'm going to get 64x plus 64. Okay, now I'm trying to get everything on one side. Right, I've got a cubic. No other hints. We're just going to have to try some values. We can see that, so remember, actually, you don't just try any old values. Like you'd never try x equals 5 because the number is going to have to divide into minus 64 because when you multiply your three brackets out, remember you're going to get that minus 64 by timesing these numbers. So you're just going to be looking at factors of 64. You can just look and see that one's not going to work, but maybe we try 2. Then it would be 24, 3 times 8 plus 40, 10 times 2 times 2, minus 48, minus 64. Well, I get a 64 and a minus 64, but I got a minus 48. This is clearly not going to equal 0. Of course, I can tell you what the answer is. I'm just talking through my steps of how I did it. Then I tried x equals 3. That will give 81. Okay, because it'd be 3 cubed is 27 times 3 is 81 plus 90 minus 3 times 24 is 72. Okay, this time it's too big. So it's actually less than 0 here. This time it's greater than 0. So that's a bit of an issue. What it actually means is that there's going to be a root between 2 and 3 because there's a sign change, but it's not going to be a whole number. What that also means is that there's no point in trying to continue with that. Well, maybe x equals 4, there'll be another one, but I think it's best to try some negatives first. And we know one of them is going to be negative because we have a minus in there. So I'll get minus 24 plus 40 plus 48 minus 64. And that will equal 88 minus 88. And we've managed to get 0. By the factor theorem, x plus 2 is a factor. Okay, I'm going to do polynomial division to work out what's left over. So it's plus 10 minus 24 minus 64. Okay, just without words, writing down, without saying it, writing down this polynomial division. So I'm going to get minus 32 here, and it all checks out. That means that x plus 2 multiplied by the quotient equals 0. Let's not forget, right at the start of the question, we were told that um, r is a positive real number. That's the base. So, okay, that's not going to restrict any of our answers. It's going to be the actual original equation that might restrict answers. So minus 2 can actually be a solution because then I'd be getting log of 0. So although it's a solution to the cubic, I'm going to reject it a bit later on. Now I can try and factorize. So there's no restriction on x other than it must be okay in the original equation. Well, if I factorize the quadratic, it's got to be 3x and x. And then if I put 8 here and 4 here, I'll get 12x and 8x. So I just need to make this one negative and this one positive. X equals minus 4, minus 2, or 8 over 3. This is that one that I had between 2 and 3 that I spotted before. If I look at the original equation, then like I said, we'll have to reject x equals minus 2, but also have to reject x equals minus 4 because we'll have log of 0 or log of a negative. So we reject both of these. Should I say y? Because reject log won't, or log of x. I just want to make it really clear. Log of x plus 2 won't exists for these. Yeah, got to be honest, I don't think that's too bad a question for question 6. It's a little bit different with the logs, but there's lots of questions like this. And in the end of the day, we just have to solve a cubic, a little bit of proof in there as well. Okay, but it's okay.